So these types of questions are common when it comes to our AP exams. Like you see a graph and they ask you to interpret it. So f is not the graph that's given here. It's actually f prime, the derivative. So be aware that these are all the slopes. The slope here is +1. The slope here is 0. The slope here is -2. The slope here is 0. And the slope here is -2 of f, right? These are the slopes of f of x, okay? These are slopes of f of x. A lot of times you can see this and all of a sudden think that this is the graph where the y value would be 1. The y value is not 1. The slope is 1. Okay? So be careful about that. So let's go ahead and start the questions. Knowing that this is f prime. On what interval, if any, is f increasing? Justify your answer. So increasing refers to that the derivative is positive, right? So f prime is positive, greater than 0. And that means your values, the y values, are slowly getting bigger, right? If your bank account is increasing, that means you're making more money. So in what intervals here is the f increasing? Meaning the f prime is greater than 0. And in this case, let's try it. Is f prime greater than 0 here? Is f prime greater than 0 here? Is f prime greater than 0? Is f prime greater than 0? Well, f prime, the derivative, which is this graph, is negative in this whole section here, right? So the only part that it is positive is this section here. This section here. So it is increasing from -3 to -2. Right? And you have to state reason why, because f prime is greater than 0. Okay. So if you look at the rubric here, the way they give it to us is they say, hey, first you'll get 1 point for the interval. Did you see that from -3 to -2, f prime is positive? Second, you have to actually state the reason because they ask you justify your answer. Well, great, it's positive. So what does that mean? Well, because it's positive, we know it's increasing. Okay, that's 2 easy points. The next question, find the x-coordinate for each point of inflection of the graph of f on the open interval. Now, what does the point of inflection refer to? You guys remember? The point of inflection is okay, the point of inflection. Sorry. So we're looking here. Since this is the derivative, I'm trying to think of something. Point of inflection. On the x-coordinate for which the point of inflection of f on the open interval. So remember the point of inflection is actually the second derivative. You guys remember that? So that's when the acceleration changes. Just to give you guys a regular graph, let me go ahead and there is something. Darn it, that's not what I wanted to do. Okay, a point of inflection is where the graph changes in acceleration. So a point of inflection would be right here, where concavity changes. This is concave up and concave down. If I went and took the derivative of this is negative. Our critical points are right here because the slope is 0. So this is a negative slope, a positive slope, and then negative slope. And this could be drawn, the derivative can be drawn as 0, 0. We go down, whoops, sorry, other way around. Our slope is negative to positive. if we take the derivative of this guy, this is f prime, f double prime, we have one critical point, 0, right in the middle here. And the slope is negative on the right and positive on the left. So we have 1 point, f prime double prime is equal to 0, and it changes sign from positive to negative. So this is our point of inflection at x equals to 0 for this example. So for the graph on the left, we have to decide at what point in this graph do we have a point of inflection? Well, since we are on f prime already, a point of inflection happens when we have a sign change on f double prime. So at f double prime, when does the sign change? Well, when does the sign doesn't either becomes 0 or doesn't exist? So if we look at our graph on our left, we notice that when does this derivative not exist? Well, the slope here is negative, the slope here is positive, and the slope here is negative. So we have to change signs someplace. We change signs at 0 and at 2. So at 0 and 2, we have our derivative is 0 or it doesn't exist. Now, do we have a sign change? Well, our slope here is negative, our slope here is positive, and our slope here is negative. So we do have a sign change at 0 and 2. So let's go back and read the question. Find the x-coordinate for each point of inflection of the graph of f on the open interval. So getting to the second derivative, we found out our critical points are 0 and 2, and we do have a sign change at 0 and 2. So here is a mistake that happens. This little sign graph I drew here is helpful to me to understand, but on the AP exam, you actually have to spell it out for the reader. You have to say the graph changes signs from a negative to positive at 0, and the second derivative, the sign changes from a positive to negative at 2. You actually have to say that. That is the justification. You can't just show the sign, hey, look at the graph. The graph says it all. You can't do that. You actually have to write it out. If you look at the rubric on the left, they say x is 0 and 2. Great. And you got points for that. You got 1 point. So you got 1 point for writing. I lost that one. Oh no. You got, whoops, not this one. Jump pages. There's so many pages here. They all look the same. Here it is. So you see that we received 2 points, 1 point for getting the points of inflection. And we got 1 point for the justification. Okay. Question C, find an equation for the tangent line of the graph or of f at the point 0, 3. So they told us write, oh, darn it, come on. Okay. They want us to find the equation of a tangent line. So since I'm writing a tangent line equation, I need to make sure that I write a tangent line. So remember, a tangent line is y minus y1 is equal to m, x minus x1. They gave us the x and y point. They told us y has to be 3 and x has to be 0. Now all we're missing here is a slope. Now what is the slope at 0, 3? Well, remember, 0, 3 is the f value. We want the f prime value. So all we need to take is the x. So when x is 0, what is the slope? And when x is 0, since this is f prime, the slope m is negative 2. Rewrite the equation, y is equal to negative, y is equal to negative 3 equals to negative 2x, y is equal to negative 2x plus 3. That is a tangent line equation. You got 1 point for that. And D is always seemingly the hardest question. Let f a negative 3 and f F4, find these values. Show the work that leads us to our answer. So this is us going backwards to find the initial value. So a couple things are given on the graph. The first statement here on our left, right here, f at 0, the actual value at 0 is going to be -3. So this, let's say this is our f graph. And f at 0 is, sorry, +3 here. Now, if we look at this, what happens to this graph at -3? Is the slope positive or negative? The slope is all negative, right? So that means this value has been decreasing. Okay? And as we were approaching +3, we were losing money. So we were losing money here. So we were from a higher point coming down. So at -2, we had more money and we're coming down, losing money. After x is 0, we're still losing money. We lose less money for a little bit, and then we lose more money. And we can find out how much we lost by looking at the area underneath that curve. And lucky for us, these are easy shapes. So let's go ahead and figure out what each of these areas are first. What's the area of this triangle here? The base is 2, and the y value is -2. 2 times 2 is 4. Half of 4, this is going to be -2 for us. On the right side, this is part of a circle, right? Wait, actually, let's work to get to -3 first. Let's find the rest of the triangle. The triangle here, half base times height. That's a 1 by 1 triangle. That's going to be 1/2 base times height. That's going to be 1/2. Okay. So working backwards from 3, if we work backwards, we are actually adding value back. We're going to add another 2. And then we're going to subtract another 1/2. Working backwards to figure out how much do we start off with. So I'm seeing we're like at 4.5. Is that right? No. So the integral they wrote is from 0 to -3. Oops, other way around. We want to find what -3 to 0 is of f prime of t dt. That's the picture that we have. And this will give us our f of 0 minus f of -3. Okay, that's by definition. We know this is 3. And we want to find out what this is. What's the integral from -3 to 0? We add up all these values here. Counting from -3 is, we said, was 1/2 plus a -2. Yep. And then we end up with here on my left side is -3/2 equals to 3 minus f of -3. Moving stuff over, that's negative, whoops, 3/2 minus 3, which is really 3/2. Sorry, 2/2, which is 6. 6 and 3 make -9/2. Negative f of -3, which is the same as 9 divided by 2 is 4.5, which is what we had before, just what I kind of said. So the calculus way of writing this is, be aware that we're using our definition for definite integrals, and then we work backwards, plugging what we know. We know these values here. We know this. We can find out what that is. We know this, and we don't know this. So treating it like an algebraic equation. The second part, finding f. So if we write f of, was it 4 minus f of 0, we can rewrite this as integral from 0 to 4 of f prime of t dt. We know this f of 0 is going to be 3. We're looking for f of 4. And then we can find the area between 0 and 4. Looking here, between 0 and 4, that is the upper part of a circle. So to do that, the trick is, you guys probably have seen this before. We draw a rectangle, and if we subtract the rectangle, subtract the circle from the rectangle, it gives us what's left. So the rectangle is going to be 4 by 2. So that's going to be a negative 8. Well, that's right, 8. 8. We're going to subtract. Let's do it that way. Let's put a negative sign because it'll be negative 8. Give me a sec. So we're at, where did we leave off? Okay, so this rectangle on our left. So we're subtracting the rectangle, which is 4 by 2. So that's going to be 8. We're going to minus the circle, which is pi r squared, right? That's a circle, half of it. So 1/2 pi r squared, where the radius is 2. So let's write that a little nicer. It's going to be 2 squared. And after we subtract this, we want to make sure it's negative because this is a negative area. Because it's under the curve, under the y-axis. So f of 4 minus 3 is equal to negative 8 minus 1/2. 1/2, 4 divided by 1/2 is just 2. It's going to be 2 pi. And we're just going to leave it like that. F of 4 is equal to negative 8 minus 2 pi plus 3. We're done. Do not do any more work to that. On the left, they distribute it, but you don't have to do that. What if you mess up? The graph of the function f, so this guy here is f, it's a regular f, shown above, consists of a semicircle and 3 line segments. They want to make sure you know these are straight lines, and that's a half circle. Let f be the function given by the integral. Let g be the function given by the integral. Now, g is going to be an integral. So one thing we want to realize is, remember, the integral is another way of saying cumulative change. So cumulative change. So starting from negative 3, we're going to go to x. So negative 3 is here. So whether we go right or we go left, we're going to add or subtract to our values here. Okay, we're taking integral, means we're going to add up all our changes. So the first question is, find g of 0. So this, when I plug it into the equation, so plug that in, rewrite it. It's from negative 3 to 0 of f of t dt. So from here to 0, look here. Am I adding positive or negative numbers? These are all positive, right? And do we have a shape for that? You can say this is like a trapezoid. So we're just adding from our starting point 2. So to rewrite this, if you want, is we're going to add starting from here, and we're going to add up all these values to the right. Okay? So let's first come up with the area of the shape here. The base is negative 3. The area is 1/2. Remember, is b1 plus b2. So the b1 and b2 is going to be here. That's my b1, b2. And the height, I'm going to take that as my height. So take that as 3. And then it's going to be 2 plus 1. Those are the y values, right? 2 and 1. 3, 3, 9 is going to be 9 over 2. So one cool thing about these types of questions, oftentimes they give you geometric shapes. So in this case, this was a trapezoid. And then, well, that's a change, but where did we start off on? We started off on 2. So this is equal to 2 plus the 9 over 2. Sorry, my bad. That's just the area from here to here. That's just 9 over 2. Okay, what's the cumulative change from here to here? Yeah. Okay, find the derivative, g prime of 0. Now remember, when we're taking the derivative, what happens to the derivative and the integral? Darn it. Fundamental theorem of calculus says, hey, the integral and derivative cancel out when we just plug it in. So we're just writing, sorry, I'm running out of space, f of t, which is 0, or f of x, which is 0, because we're going to plug in 0. So what is f at 0? F at 0 is simply just 1. Okay, second part, find all the values of x in the open interval, -5 to 4, -5 to 4, okay, the whole breadth of the graph, at which g attains a relative maximum. Justify your answer. Okay, when would g obtain a relative maximum? Okay, so what that means is, looking at this equation, as I start adding values to it, at what point do we receive a maximum value? Now, a couple ways of doing this, doing the calculus way, is we could use derivatives, right? We can look at the derivative of f, and to do that, let's write over here. So remember, to find the maximum minimum of values is you take the derivative. So when does f prime of x become 0? And we can do that. We already did that already. So g prime, whoops, sorry, we didn't do that. We said g prime of x equals to integral of 0 dx, sorry, -3 of x f of t dt. This would become f of x. Okay, and when does f of x equal to 0? Looking at the graph, f of x would be 0 here, here, and here. So a couple things we want to notice is that so if we read the answer here, f prime has relative maximum of x is equal to 3. Now, why is it that way? If you remember to find a maximum, let's look at a graph on my left here. A max is when the slope, f prime, turns from a positive to negative. And when I was looking at this graph first, I was thinking, starting here, aren't we adding values? That's what integral wants, we're adding values. And we're adding values to 1. But after 1, aren't we adding more values? Right, more values all the way up to 3. And finally at 3 is where we now start to subtract. So when does f prime go, sorry, g prime go to 0? G prime goes to 0 again at -4. It goes to at 1 and at 2. But which of these possibilities does it change from a positive to negative? A positive, negative? It only changes from positive to negative at this value here. F changes from a positive to negative at x equals to 3. Now, you might be saying, Mr. Ko, but don't we look for maximums when the derivative is positive and negative? And the derivative of f is negative here. Isn't the derivative of f negative and negative positive? Sorry, positive here and then negative. Shouldn't we say this because it changes from positive to negative? Yeah, that would be the case if we were looking at f. But the trick was we're looking at g. And g prime, the answer to g prime is regular f. So this turns out is the derivative. This is actually the g prime. This is the derivative of g. So all these values here are already the derivative of g. So the critical points would have been at -4, at 1, and at 3. And at which of these points does the slope, which is this graph here, the slope change from a positive to negative? This is a negative to positive, and positive to positive, and now positive to negative. Positive, negative, that's my critical point. Okay. Now the last part, part C, absolute minimum. An absolute minimum is when the slope changes from a negative to positive, right? Negative to positive, negative minimum goes from a negative to positive. That's f prime, or in this case, g prime. And this is a critical point, or undefined. And then we're going to say, after we do this, we have to check the endpoints if they matter. Okay. So let's go ahead and look. At what point in this graph do we have a change from a negative to positive? We have a negative positive right here at -4. So let's see. If it's -4, see, they missed a -4 here. So there's no other candidates. So we want to check the endpoints. So they go ahead, just to finish this off, they go ahead and check the endpoint at -5, and they check the endpoint at 4. So here's one thing when you hear the word absolute on the free response question, not only do you have to look for that critical point, you also have to look at the endpoints because you're comparing. Unless if you can guarantee the graph looks just like that, we have to look at our endpoints. So looking at these answers, 0, -1, and 13 minus pi over 2. The lowest number here is going to be -1. Okay, absolute minimum -1. Let's do the last one real quick before we run out of time. Find all the values of x for the interval between -5 and 4 at which the graph of g has a point of inflection. Okay, back to point of inflection. Point of inflection is which derivative? Let's talk about second derivative. That's g double prime. To get to g double prime, we're going to take the derivative of this graph. So we're going to take apart this graph. So when does this graph either have a derivative that equals to 0 or the derivative doesn't exist? I'm going to draw my little number line here just so I can see it. So find the values of x on the endpoint interval in which the graph has a point of inflection. So looking here, that doesn't exist. If I take the derivative, that doesn't exist. That doesn't exist. That doesn't exist. Sorry, this is 0 here. That does exist, but that's 0. So we're looking at -3, 0, 1, and 2. These are the points where the f double prime is either 0 or doesn't exist. So what's the slope? Do we have a change? The slope change from positive to negative. We see the slope, positive increase to negative, plus to minus. That's a minus to minus. This is a decreasing to increasing. Hey, that's increasing. And then from increasing to decreasing. So at what point do we have a point of inflection? Only when we change signs. So we change signs at -3, 1, and 2. So stick straight to that definition of point of inflection. Second derivative, change signs. So -3, 1, 2. Okay. Okay, there's another practice problem on here, but I think we're out of time for today. Can I answer any questions before we stop here?